Hello, Mohammed, you
Yes,
may
we can.
continue.
We can hear you.
So good afternoon, and thanks so much for the opportunity. Latifatu Mohammed. I'm speaking from the Council for Scientific and Industrial Research, the Institute of Industrial Research. I'll speak on synthesis of manganese oxide from Ghana's manganese ore for high performance lithium-ion batteries. Next, please. Next slide. Okay, so manganese is a common ferrous metal, and it constitutes roughly 0.1% of the Earth crust, and that makes it the 12th most abundant element on Earth. Next. Next. All right, so where does it come from? There are two major minerals containing them. A lot of them actually, but in Ghana, for example, we have the radiochrosides and then the pyrrolosides, which is the manganese oxide ore. Next. So we can see that the pyrrolosite, which is the manganese oxide, is we have about 63%, which is classified as a high grade. And then the radiochrosite, which is the manganese carbonate, it's about 47.8% and is classified as low grade. Next, please. All right, so the production by volume in 2020 worldwide, Ghana comes fifth in production of the manganese carbonate ore. Next. Wish I could do this myself. All right, so the Ghana Manganese Carbonate Manganese Company is the only manganese producer and exporter in Ghana. The Ghana government owns about 10% of the concession, and then the 90% is privately owned. And the Insuta manganese ore is considered to have the highest manganese to iron ratio. That makes it very good for manganese metal production and alloying. Next. Hello, can you hear me? Hello.
Yes, you're back.
Right. Okay, so in 2018, they had the highest production, but then there was a decrease in 2019 due to litigation issues and other problems the concession faced. Next. Yes. All right, so the primary, what the concession, the company does is Ghana just mine the manganese ore, then just export directly. There is little or no addition to make extra income. The oxide or the carbonate of manganese in its natural state has little commercial importance. Please move on. All right, so there's exportation by Ghana between 2015 and 2017. We realize that it still keep going up. We keep importing and exporting the manganese ore without adding any value to it. Next, please. Right, these are some of the works. Scientists, researchers have tried to add value to it, but much has not been done. We just, Mohammed et al., for example, characterized the manganese oxide by just extracting the metals and quantifying the concentration. Amankwa et al. Also worked on it, but so not much work has been done. Next. Next. Okay, so some work on the manganese. This is some work done from Brazil. They tried to synthesize lithium manganese oxide from the tailings of their work, and they showed interesting results. Please move on. So little has been done so far to add value to the manganese ore. There's no well-developed processes for the synthesis characterization. So this work seeks to synthesize innovative manganese-based compounds from the ore that is mined in Ghana. We assess its potential usage as lithium, for example, in this work is to assess its potential application as lithium-ion battery material. Please move on. All right, so these are some of the products that can be retrieved from the manganese ore through either chemical synthesis or thermal synthesis. Please move on. So lithium-ion battery is a hot cake now because of the advance of electric vehicles. So a lot of work is being put in there just to come out with efficient and then better lithium batteries to drive the electric industry. Please move on. So here we are trying to see when you open a lithium-ion batteries, we have the two electrodes, the anode and then the cathode. So this lithium-ion batteries normally will have a current collector with the active material. So one of this active material.
You have a minute left.
You are trying to work on. Please move on.
You have a minute.
Move on. All right, so we are talking about manganese oxide because it's cost effective, low toxicity, and it's highly available. Move on, please. Yeah, so in our preparation, we use the chemical synthesis where we leached with mild acid solution to get our manganese oxide. Please move on. All right, so this is the process. We get the coke and then we use hydrothermal process to get the manganese oxide powder. Please move on. All right, so please can you go to the results? Move on, yes. So these are our results. So we realize that the manganese by SRF, the manganese we had was the high grade type. So we also compared our results with existing literature work that has been done, but we realized that the manganese we synthesized had a very comparable total pore volume. The surface area was closer to some of the works that has been done and even better. Please move on. So we also did the XRD and then SRF, and we realized that it was the gamma manganese phase of the manganese oxide we synthesized. Please move on. Please can you go to the battery performance? Yeah, so we prepared the lithium-ion batteries using the manganese oxide prepared. We prepared the coin cell just for testing. Please move on. Okay, so this is the discharge, the oxidation CV of our material. We realize that it can store charges and release them when please move on.
It's time, Latifatu.
All right, so I'm done. Go to the conclusion, please. So there's a charge discharge properties. It's performed, yeah, so here we compared with what is in literature. Please can you just move on? Okay, so in summary, okay, so it's possible to actually synthesize from the manganese carbonate ore, and what we showed is a step for further works that needs to be done. Thank you so much.